All right, Mr. Elison's math classes, good to have you along today. This is the Chapter 7 review for our test coming up, data analysis. I'm going to go through the review so that you have access to how these work out if you have any questions. But if you have not done the review yet, I encourage you to stop this and do that first. Then if you get stuck, you can come and check out the video to see how they work. Here's question number 1. Find the mean, median, mode, and the range of the following data set. The mean is simply the average. That means to take every number in the set and add them all together and then divide by how many there are. So in adding them all together, I get a total of 36. That's by adding all the numbers. There's 9 of them, so I'm going to divide by 9, and that's going to give me a mean of 4. The median is the middle number, so to do that I need to rearrange these numbers so that they go from smallest to biggest. You'll notice right here I've done that. I've listed them all, and once I list them smallest to biggest, I like to count them and make sure I've got all 9 so I didn't miss any. And then I'm just simply counting to the middle, and 3 is my middle number. That's the median. Median means middle, okay? Mode is the most reoccurring number. You'll notice I have some repeats in here. It looks like 1 is going to be our most common repeat. There's 3 of them. That's the most reoccurring number, so I'm going to say that the mode is 1. The range is simply taking the biggest number and subtracting it from the smallest, subtracting the smallest from the biggest. So 15 minus 1, which is 14. There's question number 1. Question number 2 states here at the bottom, find the standard deviation of the following data set. That data set is right here. When I want standard deviation, remember I want you to do the simple thing and just Google search a standard deviation calculator. The first one that comes up will be fantastic. You simply enter those numbers. It'll tell you the standard deviation. When you enter those numbers in, it'll give you something real close to 14.16. That's the easiest way to do that. Just Google search a standard deviation calculator, okay? Number 3, find the value of x given that the mean is 6. Now in this case, when we want to talk about the mean, remember we're going to add them all up and divide by how many there are to get our mean. In other words, I'm going to go 2 plus 8 plus 9 plus 7 plus 6 plus x, and then I'm going to divide that by 6 because there's 6 of them. That's how you find the average. Well, in this case, the average is 6. That's what it tells us here. So the question is, what number am I missing so that this all works out? Well, to solve this algebraically, the first thing I want to do is get rid of the 6 in the bottom. That's a division, so I'm going to multiply by 6. And that will get rid of that, and I'll do it over here. The other thing I can do is combine some like terms here. If I add up all those numbers on top right there, I'm going to get 32 plus the x, and then over here I have 6 times 6 is 36, okay? Now from here, all I simply do is subtract my 32 to solve for x, and I get that x is 4. My missing number is 4. That's the number it needs to be so that I get an average of 6. So that's how number 3 works. Number 4, state which box and whisker plot represents the data. Now, in order for me to understand this, I need to know the 5-number summary. Remember the first, this is the low, the other end of the whisker is the high, and the box is the 3 quartiles. So my data up here is all listed in order, which is fantastic. 34 is the low, 60 is the high. So I'm looking for one of these that begins at 34, okay, which is probably, this is a 30 and 30, so it's got to be one of these top 2. It finishes at 60. That leads me towards this very first one here. It has a low of 34, a high of 60. If I count to the middle on this thing, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. It looks like the middle is right there at 45, and you'll notice my middle of the box is at 45. And then if I count to the middle each way again, I get a quartile 1 and a quartile 3, so the end of the boxes should be 38 and 50. That's my 5-number summary right there. So that's the one I want, okay? Number 5 says, the following data set represents the hours of TV watched. Identify each number of the 5-number summary set. So just like the previous question, I need the 5-number summary again. That means I want to put this in order again. So to list these numbers in order, I'm going to list them as smallest to biggest. So it's going to look something like this. Once I do that, I've got my low, I've got my high. I can count to the middle, which is going to be this first 4, that's quartile 2. I count to the middle again, and I count to the middle again, and it looks like I'm going to have 2 and 5 as my quartile 1 and my quartile 3. So my 5-number summary is going to be 0, 2, 4, 5, and 6. Okay, and that'll lead us to, so as you do your drop-down menus, there they are. The low is 0, quartile 1 is 2, the high is 6, quartile 2, the median is 4, quartile 3 would be 5 based on our information here, okay? Number 6, based on the 2 box and whisker plots, which class period did better? Now, when you're looking at these boxes, notice the first period, the box is longer than second period, but it's also shifted down the number line a little further. Class period 1 has a lower low, but it has a higher high, but the numbers are more spread out because of the box being so long, okay? But notice period 2, the box is shorter, but the majority of the box is shifted just a little bit to the right from class period 1. This tells me that most of the scores are right here between 80 and 90, which is going to be higher altogether than first period. So for this case, I would go ahead and say that this very first answer right here is the best one. The second, because the box is shifted to the right further, so more scores are higher. Number 7. The histogram below shows the test scores of 51 students. Match the question with the best answer. The first one says the number of students that scored between 41 and 50. That's this bar right here. It's kind of hard to see on your video, but when you're looking at your review, you'll be able to see that better. It wants to know how many students are in that area right there, okay? And that looks like it goes up to 12, so I'm simply going to put 12 right there. The number of students that scored 61 or higher. When it says 61 or higher, this is the bar that says 61 to 70, but this is higher than 61 as well. I need both of these bars added together. This bar is 7 total. This bar is 3. So if I want everything 61 or higher, it's going to take both of those bars. That's going to be 10 as my answer, okay? Now, the next one says how many students scored 50 or lower. So this bar ends at 50, and everything lower is going to be combined. That means I have 12 here, I have 6 here, I have 8 here, 4, and 1. And I've got to add up all those. I want all of those bars is what that score is going to be right there. And when I add all those together, that should be 31 if you add that up. And then it says describe the distribution. Symmetrical means it would be the peak right in the middle, and then it kind of falls each way. This one, I'm going to think the peak is barely, just barely slightly shifted to the right. That means we would say a slight skew left is what we would say on that one, okay? Just barely. That's, as far as data concerns, that's pretty close, but we're going to say a slightly skewed left for that answer. Okay, number 8. Which of the histograms match the data? Now, for me, what I'm looking at is D probably isn't an answer choice because that looks like there's going to be a bar for every single number. That's not histograms work. Histograms, we want to use a range of numbers for each bar. I think A, B, or C is our better choice. I might start, I'm noticing up at the top, they all finish with 1, 40 to 44, 42 to 45. There's only one number in the 40s, so all 3 of those are accurate for that. Maybe we should look at the first smallest set of numbers. This is the one that goes from 26 to 28. These two go from 26 to 29. If I look at 26 to 28, I have 1, 2, 3, 4, 5. That's from 26 to 28 as well. There's 5 of those total, which is what this one says, that it goes to 5 for that number range. If I add a 29, which these two have, I'm going to add 1, 2, let's see, 2 more, which makes 7. Okay, and that being the case, that could fit that. But then if you keep going, this one's not going to work for sure because that one's only a 5. Okay, I thought I had 3 of those, but maybe I just have the 2. And then what we can do is just keep adding. So far A and C look pretty good, but if you keep going here, you're gonna find that C, if you count from 29 to 31, you're gonna have 2 of them, just like it says. And if you keep clumping that data into these bars, you'll notice that C is the one that's gonna match them the best. Okay, question number 9. Match the answers with the statement to the dot plot. Okay, the highest number of siblings. So this is your number of siblings on the bar. This means there's 2 people that had 4 siblings. The highest number of siblings is 4. There isn't anybody that had any more than that. The number of people less than 2, well, here's 2, but we want less than. That means 0 or 1. How many people is that? That's 5. Okay, so we want the 1 and the 0. Those are both less than 2. The mode, again, is the most reoccurring number, or the number that happens the most time. I would say that's our 2 right there. Okay, there's 5 people that have 2 siblings. Number of people surveyed, well, that's just every dot on here. That's how many people there are. And if you count every one of those dots, your total becomes 15. You have 2, 5, and then you just keep going. There's 15 total dots. The shape of the data, this is a perfect symmetrical data. Highest peak here, same numbers on each end of it. We're going to say this is symmetric in every way. That's as perfect as you can get on symmetric. Okay. Number 10. We have an ice cream. This didn't print too well, but hopefully you can see these dots are all increasing here. What type of correlation exists? Since this is rising to the right, we're going to say it's a positive correlation. And thinking on a line of best fit, if I were drawing one of those in, it's pretty tight. That's a pretty strong positive correlation. We're going to go with that answer right there. Okay. Number 11 says which equation best fits this particular line of best fit for this scatter plot. This is section 4.4 that we did in our assignment work. So the equation, if I want to look at this line, as it approaches the y-axis, it looks like it's going to cross the y-axis at 0. So first of all, I need a number. This is saying we're going to cross at 6. This is going to cross at 2. So I know that's not it. That's not it. It's not going to cross at -3. It's going to cross at 0, which narrows me down to these 2. When there's nothing out there, that's like saying +0. Now from here is a pretty easy elimination. Do I want my slope, my rise and run, to be 2/5 or -4/5? Well, if it were -4/5, it'd be falling to the right. So this has got to be my answer by default. But what it says is we could take a couple random points on here and we could count the rise and the run, and we could be going up 2 and over 5. 1 space is 2 units, over 1 space is 5 units. So 2/5 would be a good representation of the slope. All right, finally, number 12, our last question from the scatter plot. How many hits would a batter expect to get if they were at bat 40 times? So that's just to look at this thing and say, well, here's my number of at bats along the x-axis. There's 40. What can we predict? If we follow that up to where the line is, where are we going to be? And it looks to me like we're going to be at about 16. That's how many we could expect them to get. So there's your review. Hopefully that'll help you, and good luck on the test coming up. Have a good day. Bye.